Many games rely on the result of rolling 2 dice during gameplay. A typical die contains the numbers 1 through 6, which means rolling 2 of them can result in any number between 2 and 12. The question is, are all of these rolls equally likely? Well, no, and it's not that hard to see why. For example, there's only one way to get a 2, a 1 and a 1, and only one way to get a 12, a 6 and a 6. So 2 and 12 will be quite rare because there's only one way to get either of them. However, there are 2 ways to get a 3, a 1 and a 2, or a 2 and a 1. In this manner, we can go on and compute how many ways there are to get every number. A nicer way to do this is to organize the sum of the 2 dice in a grid, with the first die along the top and the second die along the left. Then we can fill it in with all possible rolls, using the number above for the first die and the number to the left for the second die. 2 and 12 occur once and 3 occurs twice, as we've already established. We can count up the occurrences of other numbers to finish filling out our table. To turn these into probabilities, we simply divide by the total number of possible outcomes. This grid contains all possible outcomes, and there's 36 of them. Dividing each number here by 36 gives us the final list of probabilities. For example, there were 6 ways to roll a 7, and dividing 6 by 36 gives 0.1667. So with 2 dice, you can expect to roll a 7 almost 17% of the time, which is a lot. And that's why games from Craps to Settlers of Catan have special rules for rolling a 7.